Once more, welcome to the fifth in our spring virtual series. I am Kelly McBride, your current president of the Sealant Waterproofing Restoration Institute. And today we're going to hear about a terrific and challenging restoration of a historic masonry structure. So I want to thank everyone for taking time out of their day to participate in enriching our knowledge of the industry, as I believe that it is really important that even in this time when the jobs are coming at us fast and furious, we still need to take, some time and balance our lives to hear stories and updates from our industry. With that said, I also want to thank our sponsors for today's event, three longtime members of the Institute, Spider, Dow Silicones, and Sika. Obviously, your support for their companies and how they add to our knowledge is very important. So both Dow and Spider have sponsored at our gold level that entitles them to a quick update on their companies and products. So now I want to hand it over to Jim Doherty, excuse me. If you're from Philadelphia, it's Doherty. If the rest of us would be Doherty. So Jim Doherty of Spider to give his 5 minutes of attention from the best in the Sealant Waterproofing Restoration Institute. It's all yours, Jim. And you're muted now.
And Jim, go ahead and unmute yourself.
Hey, Jim, we can't hear you.
I should mention that I've been using Spider for a long time.
I think I got you.
There we go.
There we go. Now we got you.
Is my screen showing?
Yes.
Yes.
Okay. Get about 5 minutes to run through this. Basically, I want to introduce you guys to a new technology that Spider has developed to help contractors with problems that are really rampant on some of the job sites. The most common problem that we've encountered and that most contractors come to us that have encountered is a power supply issue on a job site. Power supply issues arise out of many different situations, such as using generators on a job site when the power is no good in the building, low voltage, damage from power cords or water in your plugs. Sometimes you're have lost time on the job sites because electricians don't hook up the power in time or don't show up on time, so you lose time as well. So we've worked on a solution to actually help you out with your power supply issues on the job. We've actually developed a hoist that now runs on a lithium-ion battery. The benefits of working with a motor that actually runs on a battery as opposed to a power cable is that you pretty much own your own power. When you show up on the job site, you're not relying on others from electricians. You don't have power cords hanging down off the side of the building. You're not going to lose any kind of productivity due to bad power or issues with your power supply. The motor itself's been on test since about last September, and we've had really great feedback from our customers. Some of the people we've been working with use it for quick hits with single baskets to do punch list items where they don't have to go back out to a job and drop power cords or try to supply any kind of power to the swing itself. We found that the contractors are using about 15% of the battery life in the daytime. The biggest question is always what happens or how long does the battery run for? We're seeing that we get about 3.5 hours worth of battery runtime out of a motor. And how that relates basically is if you had a 500-foot building and you went up and down, it would give you a 1,000-foot run worth of travel. You can make 7 round trips on one battery charge. So it should last you more than a full shift to actually get your work done. The battery comes with a lithium-ion battery pack about the size of a small car battery. The battery has a battery management system to protect itself from abuse. It also won't allow you to charge it at temperatures lower than it's allowed to or above than it's allowed to, so to keep the battery alive and keep it lasting much longer. It's designed to be worked in the rain, so it is rated to an IP64 standard for moisture. It also charges on a 110-volt battery. So, I'm sorry, 110 volts. So it charges basically with the same type of charger you would use to charge your laptop. It takes about 8 hours full to go from a 0% charge to 100% charge. And if you're only using 15% of your battery every day, you probably get away with charging your battery about an hour or 2 hours to bring it back up to full power. People that'll benefit basically is if you're working on buildings with bad power, if you're working in areas in the summertime that get brown power, as they call it, from having the power grid cut back on the power supply. High-rise buildings where power cables are very long and very heavy and start to overload your platforms. Buildings that have inconvenient rooftops. Also, if you're working in areas where there may be a pool or working over water, it eliminates the potential for an arc or risk hazard of getting water tied in with your power supply. The other thing we find it's very important is that some buildings, residential buildings and some court buildings and other buildings will require you to pull your power cords up at the end of the shift or your wire ropes at the end of the shift so they're not slapping up against the building and bothering the people that live in the building over the weekends or at nighttime. So this will eliminate you from having to pull that power cord up and re-drop your power cord, which could cost you an hour on each direction every day and only give you about 6 hours worth of work time out of your employees.
Here's what I found.
If the battery runs out of charge while you're in midair, as you're traveling in a down direction, it actually creates electrical charge and recharges the battery. So it will allow you to bring your swing down to the ground. If by chance that didn't work, you could also use the control descent that's required to be on all hoists that you guys will be using right now as well. Like I said before, it does work in the rain. It's protected from the rain with an IP64 protection. You cannot charge the battery while you're actually operating the battery. It's either going to be feeding juice out or taking juice in to recharge itself. And the battery will protect itself and not allow you to do that. 3.5 hour battery life will last you at least more than a full shift, as it said. We are looking to have this launched in summer of 2021. So reach out to your local branch and we can supply you what you're looking for. And that is my presentation on the battery powered hoist, but it has had really great reviews from the customers that have been demoing the equipment.
Well, that's probably a long overdue addition to our access industry. So thanks for that, Jim. And I'm going to contact you after the meeting and see if you have a show special for me. Get a couple of those for my company. So with that said, we're ready to hear from Frank Zung of Dow Silicones on what's new with their company and product lineup. Frank, are you ready?
Yeah, thank you, Kelly. Share my screen. Can you guys see my screen?
Yes.
Yep.
Okay. Hi, everyone. My name is Frank Zong. I'm the technical engineer for Dow Silicon Corporation. And today I'm going to just give you a short introduction of one of our new additions to our silicon sealant family, which is the Dow Seal 778 silicon liquid flashing. The Dow Seal 778 silicon liquid flashing provides solution for sealing rough openings, details, other buildings transitions. It offers compatible transitions and detail sealant for use with all Dow brand sealants and Dow Seal brand air barriers. It has aggressive adhesion to a wide variety of construction surfaces, including different type of brands of sheetings, cut edges of sheetings, concretes, bricks, concrete masonry units, and metals. It has a unique formulation that offers a longer time tooling for ease workability when sealing large opening, door openings, and long lengths of transition joints. Also, the Dow Seal 778 liquid flashing is the ideal sealant for flashing windows, door openings, or when you needed to seal difficult transition between materials and behind the exterior facades. Some of the typical property of this Dow Seal 778 silicone liquid flashing is one part neutral cure sealant. It has 40 short A of diameter, 250% on elevation, have primary adhesion to various surfaces. It's a low VOC, UV resistant, 210 PSI tensile strength, and a 30-minute working time. The Dow Seal 778 silicone liquid flashing is a liquid applied detailing sealant ideal for punch opening windows, auto transition, the advantage of using these products. Few step to detail, no primer needed, long tooling time, good flow for tooling at complex geometry, high diameter, good toughness, and a very cost competitive. And as I say, this is a short introduction of one of our newest additions. So I want to thanks again to SWI for the opportunity. And if you guys have any question, regarding this product or all the other products that we offer for Dow on the Silicon family, just feel free to drop me an email or contact me with the email here listed. So I'll get back to you, Kelly. Thank you very much.
Well, thank you, Frank. And again, that's another one that silicones are starting to really penetrate that general construction market. And we're happy. Thanks for bringing that to us. With that said, again, thanks to our sponsor. Be sure to support them. And Jennifer, are you ready to go to introduce our main event?
I sure am. Welcome, everyone. So before we get started with Josh's presentation, which we know is going to be great, we want to let everybody know you're on mute, and we will take questions at the end of this session. So if you do have a question, just send a chat to Nicole letting her know that you've got a question. And then at the end, she will call on those of you who have questions. And when she calls on you, you can take yourself off mute and ask your question. You could also send the whole question in chat to Nicole if you prefer that, so that we'll take them that way as well. So without further ado, let's just get right into the main event today, which is Josh Brundige with Standard Restoration and Waterproofing Company. Josh is passionate and dedicated to the preservation and conservation of historic structures. He was the recipient of the Craftsmanship Award from the Building Congress and Exchange, and additionally the Baltimore Heritage for the historic brick and stone restoration of an 1877 police station, still in operation. He recently completed a masonry project of 156 limestone units for windows, doorways, columns, balustrades, and stairs dating from the 14th through 16th century. So Josh has been in the industry for 15 years. He's worked at Standard Restoration and Waterproofing Company for the past 6.5 years. So without further ado, Josh, you can take it from here.
Absolutely. Thank you so much. And thank you everybody for being here. I'm going to open up my screen and start the presentation. So St. Paul's Episcopal Church, the restoration project was actually started in response to a series of hurricanes which caused a lot of leaks into the church, at which point a series of architects and engineers were consulted, at which point some of them were stating that the steel structure was rusting and corroding, which is why there was a lot of ferrous staining leaking onto the building. And a parishioner of the church and local architect, Joe Opperman, stepped in and was very familiar with the architect's work and knew that this was going to be a full stone assembly. So there is no steel frame. So with the coordinated effort of the architect, general contractor, conservator, ourselves, and the conditions assessment, vertical access, everybody teamed together and put together a series of mock-ups and samples, and we're able to put this project together and make it happen. So with further ado, St. Paul's Episcopal Church, just a brief summary of who they are. They've been in operation since 1876. This building was completed in 1928. On the left side of the screen, you'll see a series of outreach and programs. So this church is very active in the community, which meant a lot to me throughout learning the history of the church. And then also after our restoration attempts were complete, they were added to the National Register of Historic Places, as well as receiving the Gertrude Caraway Award of Merit from Preservation North Carolina. So for our project summary, for our company, we spent 21,000 man-hours on this project. Our first day was in April of 2019, and the 360th day on site was in July in 2020. There's a total of 36,000 square feet of building surface, as well as the daily facility for daycare, as well as weddings and funerals and other events that were taking place, as well as we had the impact of COVID right towards the end of the project. Something that we'll go through in better detail is it was found to have asbestos in the 1970s repoint mortar, which created a big challenge to overcome. And then on the lower part of the screen, you'll see that all three quarries where the stone was original in 1928 are still in operation. So why are we here? Why is Standard Restoration here? We are here to fix the water infiltration throughout the church, fix the failing flashing systems, deal with the biological growth and the ferrous staining, which was previously confused with a steel structure, but as you can see on the right, it is an iron inclusion, which is causing the staining. Also mortar failures in the corroding steel lintels, which you can see on the photo below. The general assessment photos taken in that initial effort between the architect, the surveyor, and the historical consultant, you can see a lot of biological growth, not only on the stone, but also in the mortar. You're also going to see a series, and I will scroll my mouse, around the lead flashing around the water table. This is not only exclusive to the bell tower, it was systematically throughout the entire building. So you can see on this top right photo, the missing section of lead flashing has actually been damaged and tucked back behind the mortar, which is only going to cause additional leaks. The things that we did not know, again, as previously mentioned, the historical conservator ran a series of tests on the mortar, at which point it was passed along to a professional testing agency, at which point it was identified that there was 2 to 3% asbestos in the repointing mortar. At this point, we had the full understanding that the project was going to be canceled, that there was no way it was going to be financially or feasibly possible to restore this church, which was very disheartening to a lot of people. But through a series of communications and months of work on mock-up samples and details, the architect, the conservator, ourselves, as well as a local asbestos company, were able to team together and put together a work plan, which had to go through the EPA as well as the Department of Health for North Carolina. And they said, if you can make this work, then it should be okay. So we picked back up the project, and the major task that we performed, as discussed, was 36,000 square feet of ACM mortar abatement and the tuck pointing of all masonry joints. We removed EPDM membrane across various surfaces, as well as applying a reinforced liquid membrane. We cleaned 100% of the stone surfaces via biological, atmospheric, bituminous, ferrous staining, and calcite runs. We had 3,200 locations throughout this building for grout injections and crack repairs. We had the systematic disassembly and archaeological rebuild of 4 balcony traceries, 6 gables, 2 parapet knee walls, 2 stone window jambs, and 1 chimney, which comprised of over 550 pieces and 160 lineal feet of new lead flashing. We had 2,100 cubic inches of patching and Dutchman. We had 32 locations and 800 lineal feet of new lead flashing. And we also had overhead patching and waterproofing repairs on a bridge. So to start off, the top left photo is the 1970s repoint, at which you can see there are sections missing. There is cracking, webbing, and a stark contrast in colors. On the bottom left is what we have installed. So how we got in the difference is, as you can see on the photo to the right, a series of local sands and mortar available to us. We ran through 27 different mortar samples for not only the color, but also the texture. And also we ran through 3 base colors, which can be seen on the right side around these hockey pucks. We ran 3 base colors for the stone patching. So how did we get to this stark contrast in the mortar? As you can see again on the left side is the 1970s repoint, but the piece in my hand and the photo to the right is actually the original mortar from the 1928 assembly. One challenge we often find in our industry is previous restoration attempts, overcutting. So as we can see here, there's a series of damages that was caused by previous restoration attempts by overcutting, rushing, not being trained, not taking your time, not finding the stone edge joints. And this last photo, as you'll see on the bottom right, is actually a full piece of stone that somebody decided that there should be a 1 1/4 by 1 1/4 mortar joint, even though there's no crack and no original mortar joint in that location. So how do we properly repoint, especially these very small joints? If we are going to use a grinder or a Dremel of sorts, then we need to cut a relief joint. We need to find the stone edges, we need to cut a relief, and we need to fold the mortar into that relief to prevent any stone damages. And when you're able to do that successfully, this is what it should look like. And after mortar is installed, so one of the questions you may have is, why is he using a sponge? One of the techniques that we used, as you saw in some of the photos earlier, to bring out the texture and to bring out the aggregate in the mortar, which best represented the original 1928 mortar, we used a similar technique that you would see with mosaics or with tile work. You would clean the edges with a sponge, and then we would run over the mortar joint with a saturated sponge to where we can just knock off just a little bit of that top layer of mortar to bring out that depth, to bring out the texture in the mortar. This building had 3 chimneys, 2 of them quite large on the southwest and northwest corner of the building. As you can see, there's a lot of staining. This is an active boiler. And in the photo to your right is actually the mortar that's holding this chimney together. And through time and deterioration, this is now dirt and sand. Everything has eroded away. And with that, we found a series of stones that had become loose before our abatement or our repointing efforts. So just a representation of the staining that was occurring. It ran from the top of the chimney and it continued all the way down to the ground level. So for the repairs that we did specifically on this chimney, once we removed the EPDM, we were able to find a piece of metal flashing with hammered in lead wool and hammered in lead wool on top of a ferrous cramp. As I spoke earlier, we had some loose stones, at which point, due to safety concerns, had to be systematically removed, at which point we consulted with the architect, the GC, and the historical consultant, at which point we all agreed that the loose stones needed to be removed, restored, and pinned and reinstalled appropriately. And here is a before and after shot as far as the cleaning. This is a sample of an as-built that we submitted. I have omitted a lot of the materials, but if you follow me on the bottom left side, you will see a before and after cleaning. We added new stainless steel cramps to reinforce and tie in this chimney for structural reinforcement, and then we applied a reinforced liquid membrane across the top. You can also see a series of holes. When we would remove some of the exterior stone, we were able to see inside the flue chamber, at which point those cavities needed to be sealed up and the stones needed to be reinstalled. So as a good before and after, the photo on the left is going to be the southwest chimney. The photo on the right is a before of the northwest chimney. And this is an aerial view from the actual tower of the church. And then this is an after. Some of the other challenges that we had, on the top right is a buttress cap. This is actually for the winding staircase to lead into the tower. And one of the things that we identified is with the lead flashing, which is obviously cut back and damaged, in the lead flashing at the joints and at the overlaps, there was 30% asbestos insulation used at that location. So not only did we have mortar, but we also had insulation that needed to be abated. So on the top left, once the scaffolding is removed and all the abatement is performed, you'll see the skyward surface of the coping stone. And I'll draw attention to this fragmented piece. And there's a small section at which there was a ferrous cramp that had caused, in addition to water infiltration, this movement and this fracture of the stone. So after our series of masonry repairs, we installed that reinforced liquid membrane. And this is a photo 6 months after the reinforced liquid membrane was installed. And here's a before and after photo as far as the repointing. Here's another example of our as-built that was submitted. If you follow me on the top right, this is the location as far as the asbestos mortar and the insulation. You will see that we removed the ferrous cramps. We pinned back with stainless steel. We pinned back the fragments, installed new stainless steel cramps, sealed all the joints, and then installed the reinforced liquid membrane. Again, 2 days after, and this is 6 months. As a close-up, we have, as you can see, a self-terminating installation to where there is nothing seen except for from an aerial view. Also, there's no termination, there's no hit pins, there's nothing that's going to go in, fasten to the stone, and potentially cause either water infiltration or stone damage. This is one of those examples that was drawn as far as the concern for a quote-unquote steel structure inside the church. But as we can see as we go through, these are iron inclusions. So this is specifically at door E2 on the southeast elevation. So the work that we performed here is we removed the EPDM and cleaned the stones. The coping stones were actually found to be loose, so we removed all of the sandstone coping stones, installed a new piece of lead flashing. We reinstalled the coping stones with new lead T-caps. And then this is our after. And to get a good representation, I have a before and after from the same view. On the left is our before, dark, and on the right, vibrant. Throughout the process, it was important not only to track our progress, but also with the ACM. It's very important to follow the written protocols and procedures as well as the containments. We originally had 10 containments. At one point concerned to have up to 14. But as you can see, I would send these out every week to the owner, to the client, to the architect, and to the GC, to where we were all on the same page as far as our progress. The south elevation was the last elevation that we worked on. So at the beginning of October, you can see we just did the abatement on the west elevation, which is phase 8, and we were working our way across the south. And then by the middle of January, we were almost complete with the ACM as well as the mortar installation following behind. So this was a very important tool, not only for the on-site project team, but as we are based in Maryland, it was important to communicate to our office our overall progress on a week-to-week basis. The north elevation is where we started, beyond the bell tower. So this is just another good representation as far as tracking. You can see small annotations in red around the tower. This is where I would use the opportunity to call out loose stones or unforeseen conditions or anything that might need the project team's insight or attention to. So this was a good opportunity to communicate without the email and pictures. So the ultimate challenge, which was a very tedious task, was the actual ACM mortar abatement. With this, as you can see, we had a series of PVC pipes with connections running around the entire building. Every floor required different junctions and different connections. And as you can see on the far right, you'll see a series of pipe running across the top, as well as a series of pipes running across these ornate details right below. So these were installed and connected to two 350-gallon water tanks, which was then propelled via a pump into the water hose, as you can see on the right photo as well as the left photo. It would propel water into this PVC pipe, at which point we drilled 1/16 inch holes into the backside of this pipe throughout the entire building, and it would cascade water against the building surface to soak and saturate the stone and the mortar. Now, in a building that's already leaking, you can imagine that this caused a series of issues and leaks as well. So that was a continuing challenge. One thing we also needed to do is to make sure that we didn't allow this mortar to fall more than 6 feet. So we installed a series of green netting with reinforcements to prevent any debris or any asbestos-containing material from falling down to the floors below, much less 80 or 100 feet. The next step was to perform a series of masonry repairs. The gable that was systematically disassembled was prompted because of all the loose stones. And as you can see on the top photo, we took measures to ensure that that would not happen again. We installed 3/8 stainless steel rods, both horizontally and vertically, to tie this wall section in to prevent any stone movement or falling debris in the future. In the photo to your left, you're going to see us performing a series of grout injections and stone repairs via a syringe. Also, with the cleffing of the stone, which is natural, we would go through, flush out the joint, and then we would systematically lay in a grout material to seal that edge to prevent any water infiltration, which would then, due to freeze thaw, cause cracks, falling, and potential falling hazards. On a large scale, we also saw, in an effort of that 3,200 locations spoken about earlier, a series of full-depth head joint voids, to where if we would try and repoint the mortar, there was nothing solid to repoint. And so we would have to go through and, under pressure, inject and install a grout material to provide a solid backing to our mortar repoint. Another challenging task was the archaeological disassembly and reinstallation of all of the stones around the steel lintels. So at 32 locations, we had to label, photograph, document, and measure every stone and its orientation to make sure that everything went back as it was originally installed. So once we removed all the stones, we took apart the corroding steel lintel, added a new stainless steel lintel. We custom made a single piece of lead flashing with custom end dams. So there's no solders, there's no seams, there's no joints. And then we would hammer that into a riglet, as you can see in the bottom photo here. We would hammer that into a riglet as well as the end dams. And then we would reinstall the stones. An issue that was present during the initial survey, as well as after our repointing, was a series of vertical cracks extending from the roof line going down into the windows. What was later defined and attributed to thermal movement, we performed a series of deep repointing, 3, 4, even 5 inches, at which point the cracks came back after a few months. At which point an engineer was then involved in the project team between the GC, the historical consultant, as well as the architect. We all came together and decided to install these reinforcement bars around the windows as well as at the roof line. So as you can see in the photo on the top left, we would install 2 layers of this reinforcement bar 1 inch apart to provide reinforcement at that location, as well as a series of bars around all of the window heads to provide a series of reinforcement. Another challenge that we had previously spoken about was the existing lead flashing. Unfortunately, it was damaged severely in a lot of locations, some of which we were able to work around and reinforce. Some of it we had to completely remove and replace. So as you can see on the photos on the left and the one on the bottom right, this is before any ACM removal. There is a lack of presence in existing lead flashing, as well as on this bottom right photo, you're going to see it's actually tucked behind the repoint mortar. So this is going to continue to only allow water to infiltrate and bypass this lead flashing. So what did we do? We removed all of the gable stones, we removed the knee walls, and we installed new lead flashing. At the hood molding on the bottom right, you're going to see we installed lead T-caps, as well as we slid in new 6-inch lead flashing underneath the existing, as well as going over top of the lead T-caps to better reinforce the waterproofing. And as you can see also on the bottom right photo, we had to remove stones on each side to provide new end dams and back dams as far as a water collection, as we found that the waterproofing, this lead flashing, was actually negatively sloped and holding water, at which point it had completely corroded and weathered away. So the photo on your bottom left, which is a stone medallion, we installed new lead flashing around the top to seal in and protect all of the head joints. We removed the 2 side stones, and we installed a riglet with end dams and back dams, new lead flashing going around and underneath this stone to prevent any water infiltration. So the most important and well-known stone on any church is going to be the cross. And as you can see, there is a series of biological and atmospheric staining to the cross, at which point, through several days and through several cleaning attempts, we were able to systematically remove not only the biological growth, but most of the atmospheric and other types of staining. With this process, it's always very important to understand and recognize that you don't want to immediately clean everything 100%. In the restoration world, 80% is what we're aiming for. So you've got to make sure that once you clean things, that you let them dry. So the photo in the middle, once it dried after a few days, is what resulted in the photo to the right. So you can see it's a much different color, but the stone just needed to dry. So it's important in our industry not to rush progress. For another as-built, this is for all of the gables, and specifically the one at the cross on the east elevation. If you follow me on the top left of the screen, we removed all of the coping stones as well as the supporting granite, and we had to remove all of the existing lead flashing. So by use of lead flashing, we created new sawtooth flashing with an interlocking detail, at which point you can see on the far left, it overlaps the sawtooth flashing connected to the roof, as seen here. And then as we install a specific material to prevent the stones from sliding the lead flashing or potentially damaging them, you can see here also the J-hook stainless steel detail that I referenced as far as the masonry repairs. You can see here, this is us interlocking that sawtooth flashing with the coping flashing. And then when I talk about cutting in a riglet and hammering it in, this is the detail that I am describing. So we would cut a chase into the stone and we would hammer in new lead to protect this surface. And this specific location, as you can follow my cursor here to the right, is right here. So on top of this lead flashing is another layer of lead flashing, seen here. Now, once that continues and goes up, if you follow me to the photo above, this is the back side of the same area. So you have a layer of lead flashing here. You have another layer of lead flashing underneath this stone that continues, and then we provide another layer of lead flashing on top of that as far as a shingling effect to prevent any water infiltration in the future. And on top of that, all of the head joints received lead T-caps. Through the work of the historical conservator, we were able to work in conjunction with them as far as taking apart the lanterns, which are suspected to be original to the building, except for the one to the bottom right. So through a series of efforts and cleaning attempts, as well as some material replacements, they were able to effectively restore the lanterns and reinstall them throughout the building. So to clarify, on the far left, you're going to see old patches, which is what we found as far as delaminations, spider cracking. You're going to see this fracture line, as well as this fracture line. Also, there was no attempt as far as a color match. It was a stark white compared to a beige or to a light gray. So it's important not only to provide a good patch, but also to stain it. You need to be able to match the color of the stone that you are working on. So here you can see us applying the staining material, and then you can see it here as it is starting to dry. Also in this area, due to the considerable amount of patches as well as all the cracks, it was investigated and identified that there is actually galvanized pipe that was used as dowels to hold all of these stone traceries, as you can see here. So at every joint, there is a galvanized crimped pipe used as a dowel. And unfortunately, as water gets to them and the galvanization wears off, it eroded and corroded, and it expands and contracts. And so that's what we're seeing as far as a series of cracks. So with that, in conjunction and working with the architect, the GC, and the historical conservator, it was agreed upon to systematically disassemble and rebuild all 4 of the balcony traceries. So if you follow me from the top left, you'll see one of those rusting and corroding galvanized pipes, which has also caused a crack. The stone below you can see is actually split in half, which had to be repaired. So what we did is we systematically disassembled all of the traceries down to the water table stone. Once we got down to the water table stone, if you follow to the right side, we installed a lead T-cap not only on the surface, but also throughout the entire water table to prevent any water from infiltrating this area again. Caution and care was taken, and we did water tests to make sure that no water would collect or pool or pond in this area. We installed a series of pins as labeled here. So we installed approximately 74 pins for each balcony, disassembling the coins, the corners, the granite, as well as all of these tracery stones. And as a general representation, on the top right, this is 2 of the 4 balconies. So during that process, we were able to find a couple of relics. As you can see, also on the right-hand side, where my mouse cursor is, there's a spire right here, right around 2/3 of the way up the tower around the lead-coated copper louvers, which can be seen here in the precondition survey. Now, as you can see, it's a series of mortar patches that was just thrown on there. And while we were investigating leaks, we were able to find 2 of the 3 missing pieces, which were evidently discarded during the previous restoration attempts. So the height differential, as you can see in that location, as well as the smaller and more moderate here, is actually the amount of stone that was missing. These stones were installed at the original height, but it was evident that on that middle one, that first one that we replaced, that somebody had attempted to repin that in place as there was a corroding anchor in there, and then it had obviously broken again, and they just discarded it within the tower. Now, after we were able to put that back together, we did a series of patches and color matches to blend in the stone. Another amazing feat was sometime on or about October 30th of 1928, somebody carved into one of the stones around that northwest chimney the date, AD, and M. One of the things that we found throughout the asbestos removal was around the windowsills of all the naves, specifically around the music library down in the basement, as well as the vesting room, there was a series of leaks, at which point several hundred gallons of water was infiltrating during the ACM removal. So through this process, once the ACM was cleaned and cleared and we were able to go in, we identified, as you can see in the photo to the left, as well as to the photo to the right, that piece of metal is actually the interior lintel supporting the ductwork to the nave. So water, as you can see in the middle photo, was cascading down the wall and down the window, hitting this ledge and then infiltrating the building. And obviously with little to no resistance going down the ductwork to the areas below. And as a general archaeological find, we identified that they used balsam wool insulation at this joint originally, as also we were able to find it intact in some locations and inside the ductwork at others. So what we did to repair it, we rebuilt the interior. We did a series of grout injections to seal that hole 100%, as well as reslope everything to come out. And in accordance with following the historical procedures of, if it's not original to 1920, it shouldn't be on the building, we decided to use lead flashing, which will blend in with everything else that we used, but we lined that on top of stainless steel flashing for the rigidity and strength. So as you can see in the photos to your right in the middle, you're going to see lead lined stainless steel flashing installed underneath the windowsills to prevent water infiltration. And then this is what it looks like. And then on the photo to the right, to show that what we have done is a successful repair, and to prevent water from oversaturating the stone below, you can see the installation as well as the water dripping away from the building. So the damaged stones, as you can see on the far left, this is before the window was removed. So after the ACM removal, you can see an oversaturation of the interior stone, as well as what is stone and patch. Now the photo on your right, one would think that this is original stone and this small little sliver is patch. Well, it's actually the opposite. This large section, approximately 85% of the stone, is actually a patch. So once the window was removed, we identified that the stone has deteriorated beyond repair. And so in working with the architect, the GC, and the historical conservator, it was identified and agreed, especially since the original quarry is still in operation, that we should find replacements for these stones. And just to go a step further, this stone here is this smaller one. But as you can see on this line, everything to the right is a patch, everything to the left is original. So as you can see on the photo to your left, this is us disassembling the window jamb. And then this is after we have rebuilt with new stone. This is the one on the right. And this is us installing the last stone. Now, one of the challenges that we had specifically related to this area is this is right as COVID was hitting its peak part in March and April. The quarry couldn't find anybody to operate. And so we were unable to obtain these stones for quite some time. One of the last areas that we'll look at is the bridge, as well as door E2. So this is also on the southeast side, where we saw the before and after with the ferrous staining above. You can identify on the far left side, this stone is cracked and damaged, and attempts were made previously to try and pin it back together, as well as a series of damages to the wood door, as well as you can see some oversaturation staining around the pocket of the door threshold. So we know that water's getting in here, but it's not able to get out. And when this photo was taken, it was a week after the last rain. So in working with the architect, the GC, and the historical conservator, we all agreed that we needed to take apart this threshold. Well, once we took apart this threshold, we found the interior lath of the door below. At which point we took a series of measures to install stainless steel flashing throughout the perimeter, as well as new waterproofing. And then we reinstalled new, they're pronounced NICE, G-N-E-I-S-S pavers, which is also brought in from the original quarry up in Massachusetts. So for our general cleaning, you can see on both photos the images. On the left-hand side, you're going to see uncleaned, untreated areas, and on the right-hand side, this is going to be after we cleaned it. Now, this is no repointing, no other additional measures taken. This is just based off of cleaning. For the EPDM removal and cleaning, you can see these are 2 before photos. Here's an after on one of the knee walls. And here is an after on one of the caps. Also in the ferrous stain removal, at which we've talked about before, the image on the left, you're going to see at the top stone a couple of splotches, kind of green in color. And below that, you're going to see all this ferrous staining. Well, on the image to your right, you're going to see a series of, again, that green staining. And what this is these are the iron inclusions in this stone. So as you can see, this is not just 1 or 2 spots. This is throughout this specific stone. So this is a before, and this is an after. So as an overall view on the northeast corner of the church, this is a before. This is before any scaffolding was installed. Drawing attention to, again, the yellow texture, the shadow effects up at the tower. And then this is an after. And by far my favorite view of the church, as you can see the tower, you can see the winding staircase, you can see 2 of the chimneys and 3 of the gables. This is a before, and this is an after. Ladies and gentlemen, this was St. Paul's Church. And as a memento from those windows that we took apart, we decided to have these carved and distributed amongst the project team, which you can see labeled on this plaque. So everybody, thank you so much for your time. And is there any questions?
Nicole, did anybody send you any questions?
I have not received any questions in the chat.
All right.
If anyone does have any questions, you could take yourself off mute and ask it. Does it seem?
I have a question. This is Sarah Holder. Hi, Josh. Thanks for the great presentation.
Thank you.
Specifically about the cleaning, because those iron inclusions are naturally occurring. It's great, the fantastic cleaning results. Did you guys do anything to manage the expectations of that stain reoccurring?
So we were able to do a series of applications in like the precondition survey that was performed with all the teams. So with that, we were able to work with a series of cleaners and chemicals to where we can remove just the surface staining, at which point we had to follow up with a series of poultice cleaning to try and pull that out. And then with that one specific photo with the iron visible inside that cavity, we had to go in and remove that from the surface, as well as chipping away anything on the surface and then applying water repellent in a couple of series. And that's how we were able to remediate that. But it's known that we would have to, or somebody would have to follow up, track, manage, and monitor that as time moves forward.
Okay, thank you. So they did allow a water repellent on the historic structure then?
Yes, and it was a water based, so it's not a silicone based to where it's irreversible. You have to keep doing the same thing. It's something that's not going to last quite as long, but it's going to be more appropriate as far as a historic structure.
Yesterday, Josh, when we were going through our rehearsal, you made mention of how important the hot water was.
Oh, yes, yeah. So, you try with just a regular pressure washer, and even at the same PSI, the same water, the same process, same materials, it just didn't have the same results as using hot water. So it's very important to, and what we found, not only in this project but in other projects, the introduction of hot water, so a self-contained boiler of sorts, is very appropriate, and it produces much more efficient results. So instead of cleaning something 3 or 4 times, we were able to reduce that to once, maybe twice at the most, as far as just introducing hot water.
Nice. Well, I don't know if any of the participants checked out the videos we sent out in yesterday's e-blast, but the church did a very good job of doing kind of a multi-part series of the restoration. And so you could check out a couple of those videos. There was one featuring Josh and standard waterproofing restoration. And then there was one with vertical access and their discovery phase that was in that email. But as I was looking at those, there's a lot of interesting videos to check out if you happen to go to that site.
Josh, real quick, I know that once they discovered ACM, that was a huge impact to the cost on the project. Was there a negotiation process, or did they entertain bringing in new bidders due to the expanded scope, or how about contract issues that you might have had?
So through that, again, the understanding once they found the ACM is, we were under the understanding that it was not going to be a possible project. They had brought in a local abatement company to which, they guaranteed that they would damage stones, that there was no way to save sections, that they're not masonry contractors. And so at that point, to answer your question, it was a negotiated process from there. We were able to come up with a series of work plans, at which point we contacted the Department of Health in North Carolina, as well as the EPA. And we wrote up plans, we developed a video, we were on site, we performed it in front of everybody to show that we can do this work, at which point we had to get new insurance. We had to get a new insurance policy, a new pollution control policy, which we didn't have before. And it was specifically stated that we, as the standard, can remove the mortar, but we cannot dispose of it. We can't sweep it up. We can't clean it. We can't get rid of it. That's got to be somebody else. So there was a series of negotiations and us working in conjunction with a local abatement company for that.
So that allowed you to get around retraining your crew and getting everybody asbestos certified?
Well, actually, we had to become asbestos certified. So here in Maryland is where we're based. And so everybody went through the training in the test, became asbestos workers. I went a step above and got trained and passed the test for an asbestos supervisor, at which point then we transferred everything to the state of North Carolina and became accredited asbestos removers for the state of North Carolina. But we operated underneath the license and the supervision of the local abatement company.
Well, fascinating. Great job. Thanks again for a great presentation.
Thank you.
All right. So what we thought we would do now, unless anybody has any questions, any more questions for Josh, we would go into some breakout rooms just for 5 minutes, do rotation, give everybody a chance to say hello. If I know not everybody likes doing that, if you are going to join these breakouts, please put your video on so we can see each other. And if you do not want to participate in those, you could go ahead and drop off the line now. And so anyway, Nicole's going to throw us into some breakout rooms. If there's a lull in conversation, and why don't you just tell people something that's really positive going on in your life right now, and that should keep us talking. And then we'll all meet back here after we get done with our breakouts.
Don't forget to unmute.
Yeah.
This is very important. All right, like Jennifer said, I'm going to create 3 breakout rooms. You guys will be randomly placed in those rooms. And then after 5 minutes, it will bring you back to the general session room. And then I will create those 3 rooms again, and you will be placed into hopefully a different room with different attendees.
Hey,
All
Nicole.
right. Yep.
Nicole, so now we're down to 18 people. We keep dropping off. So we could probably just do 2 rooms.
Okay. I
Or-
will recreate to do 2. Hold on.
Or we could probably all just talk to each other.
Yeah, it's not a huge gallery.
Yeah, let's forget the breakouts. I don't think many people are interested in. We got 14 people here, so why don't